Okay, here's a thought experiment for you. What is everything we think we know about the universe, fundamental forces like electromagnetism, even something as basic as mass itself, what if it isn't quite what it seems? What if these aren't the fundamental building blocks, but maybe more like echoes of something deeper? Well, prepare to have your mind maybe a little bit bent today, because we were taking a deep dive into some pretty dense but really fascinating material. Our source is coherence theory, electromagnetism, and mass emergence. And our mission, like always, is to sift through these complex ideas and pull out the most mind-bending insights we can find just for you, our curious listener.
And what's really fascinating about this source material is that it presents what it calls a Unified Coherence Theory. You might see it as UCTE. And it's proposing a really radical rethink of physical laws. It doesn't see them as fixed rules, intrinsic prescriptions the universe has to follow. It views them more as structured outcomes, maybe like patterns, that emerge from something even more fundamental, something it calls coherence, modulation, and reduction. It's kind of a vision of physics rooted not in the geometry we usually think about, but in what the theory actually calls the intelligence of coherence itself.
Right, the intelligence of coherence. And we're going to dig into how this theory claims to, derive fundamental things, electromagnetism, mass, from completely new first principles. And it reveals some really surprising ideas along the way. So yeah, let's start peeling back those layers. So let's unpack this core idea first. The UCTE suggests that classical electromagnetism, the stuff we learn about, isn't fundamental. Not at all. Instead, it seems to arise as maybe a kind of boundary condition, like a ripple effect from more primordial dynamics. These are governed by something called the vacuum coherence tensor. Can you help us picture what that even means?
Absolutely. I think of it like this. The theory lays out sort of a progression, right? An ontological cascade, as the source puts it, for how electromagnetism actually comes into being. It moves from the absolute most foundational level all the way up to the familiar electromagnetic world we interact with. So layer one, the very base, we have the coherence vacuum, which the theory also calls the omnilectic substrate. And the fundamental idea here is that, all forces and fields, they aren't really fundamental on their own. Instead, they are emergent coherence structures. Think of them maybe like patterns or ripples inside this vacuum coherence tensor. It's described as pure coherence, and crucially, it's pre-geometric.
Pre-geometric, so before space and time as we know them.
Exactly, before geometry emerges. And it's governed by some underlying action principle, almost like a fundamental rhythm or rule for this coherence.
Okay, wow. So it all starts with this fundamental coherence, almost like a substrate beneath reality. But then how does geometry, the fabric of space and time, how does that emerge from this pre-geometric state? What's the proposed mechanism?
That takes us to the second layer, geometry as projected coherence. So essentially, this underlying coherence starts to resonate, and it projects itself into geometric structures. This happens, according to the theory, via symmetry stabilization, and that leads to the emergence of the metric tensor, the going we know from general relativity that describes space-time's shape.
Okay, symmetry stabilization.
Yeah, you can sort of imagine certain coherent patterns becoming stable enough, resonant enough to form the very geometry we perceive. They call it resonance-stabilized geometry.
So geometry itself is a projection, a stable pattern from something deeper. That's a huge shift already. And then, okay, the big question. How does electromagnetism, the force holding atoms together, lighting our homes, how does that fit into this picture?
Right, that brings us to layer 3. Electromagnetic potential as metric expression. Now, the familiar 4 potential A, which we use to describe electromagnetism mathematically, instead of being fundamental, this theory says it actually arises as a kind of gradient shadow.
A shadow.
Yeah, or maybe a ripple effect from how the deeper structure of space-time itself, the metric tensor, is warped and spreading out. Technically, it's under what's called a Weyl-type divergence.
Okay, Weyl-type divergence.
In perhaps simpler terms, the EM potential is described as a divergent curvature trace. So think of it less as its own distinct field and more like the subtle way this underlying geometry bends or spreads out. And that process leaves a trace that we then perceive as electromagnetic potential.
That's wild. So the potential isn't fundamental either. It's an echo, a trace. Okay, but what about the actual forces? The things that make charges move, the fields themselves?
That's layer 4, which introduces nonlinear electromagnetic dynamics. And here, the source brings in the concept of coherence-aware field strength, symbolized as V. Now, this is where it gets really interesting because it includes these nonlinear terms represented by alpha and gamma.
Nonlinear terms. What does that mean here?
It means the relationship isn't simple or proportional anymore. This stage describes what they call coherence-tuned harmonic flow, or you could think of it as curvature feedback effects. Essentially, the underlying coherence isn't just creating the field passively, it's also dynamically interacting with it, influencing its behavior in a complex feedback loop. And this stage is what yields the nonlinear Maxwell equation.
Nonlinear Maxwell equations. Okay, so then how do we finally get back to the regular linear Maxwell equations we all learned, the ones that work so well for circuits and radio waves?
That's the fifth and, well, the final layer in this cascade. Classical electromagnetism as a limiting case. Crucially, the classical Maxwell equations we know and use emerge when you look at a very specific situation, the low curvature, weak field regime. But basically, when the underlying coherence dynamics aren't too intense, when things are relatively calm, those complex nonlinear equations simplify right down to the classical ones we're familiar with.
Oh, okay. So classical EM is like an approximation.
Exactly. It's seen as a projected linear limit of coherence modulation. The source uses a great phrase for it, a dimensional echo. It's like seeing a simplified, flat projection of a much richer, more dynamic, nonlinear reality.
You know, when I first read about this next part really made me pause. The theory doesn't just reinterpret forces. It seems to completely redefine concepts we thought were fundamental, like take electric charge. What is charge in this UCTE model?
Yes, this is where the redefinition really hits home. Charge, according to UCTE, isn't some kind of substance, not a fundamental stuff. It's described as divergence, or maybe more evocatively, a curvature symptom.
A symptom.
Yeah. It's less about having a thing called charge attached to a particle and more about how the underlying coherence field itself is diverging or spreading out or perhaps bending at a particular point in spacetime.
Wow. Okay. And what about force itself? You usually think of fields pushing and pulling, maybe action at a distance.
Right. But here, force isn't really action at a distance. It's described more like resonance curvature or maybe navigational outcomes of coherence gradient flow.
Navigational outcomes. What does that imply?
It implies particles aren't being actively pushed or pulled by a separate force field in the traditional sense. Instead, they're naturally moving along the most resonant pathways, or following the gradients, within this deeper coherence field. Their path is determined by the structure of the coherence itself.
So the field itself isn't separate either.
Exactly. The electromagnetic field isn't seen as a distinct entity overlaid on spacetime. It's more like a symmetry echo of the coherence manifold, a visible pattern reflecting deeper invisible symmetries within that fundamental coherence.
So, okay, the familiar Lorentz force, the equation that tells us how charged particles move in E&M fields. How does that specific force fit into this resonance curvature idea? Is it still valid?
It is, but its interpretation changes. In UCTE, the motion of charged particles is linked directly to what's called geodesic flow, basically, following the most natural paths or curves within the coherence field itself. The Lorentz force, then, is seen as an emergent resonant modulation. It's like the particle is just naturally following the currents or contours of the coherence field, and what we measure and calculate as the Lorentz force is simply the modulation, the effect that arises from that interaction.
So it's emergent, not fundamental.
Precisely. And this also connects neatly to charge conservation, the principle that total charge never changes. In UCTE, this isn't just an arbitrary rule. It's presented as a Noether-like symmetry of the coherence field.
Like Noether's theorem relating symmetry and conservation.
Exactly like that. It arises from a fundamental constraint on the coherence field itself, specifically a divergence-free constraint on the coherence current. It means that the coherence flow has an inherent property that manifests as conserved charge in the emergent electromagnetic description.
Okay, so if electromagnetism, charge, force. If they're all just echoes or patterns in a deeper coherence, what does that imply for, the rest of reality? Does this theory make any predictions we could actually test?
Well, that's a crucial question, isn't it? What else might bubble up from this coherence? The theory does touch on what it calls predictive extensions. It suggests that tiny fluctuations in coherence at the Planck scale, those incredibly small quantum jitters at the very foundation of reality, could directly lead to observable phenomena.
Like what kind of phenomena?
For instance, things like zero-point energy, ZPE effects, and spontaneous charge pair fluctuations popping in and out of existence in the vacuum. These could potentially offer explanations for known effects, like the Casimir effect.
Where plates in a vacuum attract each other.
Exactly. Or maybe vacuum birefringence, the idea that light could actually bend slightly, even in empty space under certain conditions. So it positions UCTE as a potential substrate theory of QED, quantum electrodynamics, hinting that it might provide a deeper underlying layer to our current, very successful quantum theory of electromagnetism.
Okay, that's a whole lot to digest just about electromagnetism being an echo. Now, let's pivot, because the theory tackles another absolutely huge question in physics. What is mass? We tend to think of it as just fundamental stuff. But UCTE apparently offers an equally revolutionary answer, one that directly challenges existing ideas like the Higgs mechanism.
That's right. Within this UCTE framework, mass is viewed very differently. It's not a fundamental attribute, but a resonant effect. Think of it as an emergent phenomenon resulting from the modulation of coherence, torsion, and chirality alignment.
Coherence, torsion, and chirality alignment. Okay, break that down. Torsion sounds like twisting.
Exactly. It's not just about the flow of coherence, but also about how it twists. Mass isn't seen as some inherent property a particle just has, but rather something that arises from the way the underlying coherence twists and aligns itself, specifically its handedness or chirality.
Handedness, like left-handed and right-handed. And the source introduces something called the chirality resonance algebra, or CRA. How does this algebra explain mass emerging from twisting coherence?
Okay, so first we need the concept of the chirality field. You can picture this as a local coherence torsion vector field. It's essentially acting like a handedness operator at every point.
An operator that says left or right.
Sort of, yeah. It captures the intrinsic twist or directionality that emerges from the coherent torsional winding of coherence flow. Imagine the underlying coherence isn't just flowing smoothly, but it's also twirling, like countless tiny invisible vortices or springs winding up. Now, the CRA, the chirality resonance algebra, is basically a set of mathematical tools, operators, that act on the fundamental coherence eigenstates, the basic states of this coherent substrate. And when these operators act, they produce resonance transitions between states.
Okay, operators acting on states, causing transitions. Where does mass come in?
Here's the aha moment, according to the theory. Mass isn't just something a particle possesses. It arises when chirality resonance stabilizes, or when it reaches a specific resonant torsional lock.
A lock, like clicking into place.
Exactly. Imagine a spinning top wobbling and then suddenly finding its stable axis and spinning smoothly. That lock in the twisting pattern of the coherence, that stable resonance, is what we perceive as mass. So the ontological interpretation, the deep meaning here, is that mass is not a field amplitude, like the Higgs field strength, but a coherence torsion phase lock. It's a topological quantization of the coherence flow's twist symmetry.
Topological quantization, meaning it's like a fixed, stable knot or pattern in the twist.
Yes, a stable, quantized pattern, which leads to the statement. Matter, therefore, is coherence geometry stabilized through chirality resonance. Matter itself is a stable, twisted pattern in the coherence.
Wow, okay, that has absolutely incredible implications for one of the biggest mysteries. Why some particles have mass and others, like the photon, don't. How does this twist lock idea explain that difference?
This is arguably one of the most elegant parts of the theory, how it handles the chirality null modes and the masslessness of bosons. So fermions, particles like electrons, quarks, the building blocks of matter, they emerge with these locked chirality phases precisely because of this coherence torsion. They achieve that stable twist, that resonance lock.
So they get mass. But bosons, photons, gluons.
Bosons, the force carriers like photons and gluons, are described as null modes of chirality resonance. This means their torsional coherence vector, their intrinsic twist pattern, is either self-canceling or it's oriented in a way that's orthogonal, completely perpendicular to the specific flow pattern that generates mass.
So if they don't participate in that specific torsional lock, they don't acquire mass.
Precisely. They don't click into that stable mass-generating resonance. This provides a direct explanation for why photons are massless. They're described as a specific kind of U1 coherence projection, a symmetry manifestation that doesn't involve this torsional lock. It also explains why gluons, the carriers of the strong force, are massless. They're seen as SU3 torsion-neutral mediators. They mediate the interactions, carry the force information, but remain neutral to this mass-generating twist.
And what about neutrinos? They have a tiny mass, right?
Yes, and the theory interestingly hints at the effective near-masslessness of neutrinos by suggesting they might be partial null mode states. Almost null, but not quite, allowing for that very small mass.
Interesting. So bosons are just messengers, in a way.
Essentially, yes. In this framework, bosons are viewed as pure symmetry carriers that transmit coherence transitions between fermionic states. They carry the message, the interaction between the matter particles, but they don't themselves participate in the twist-lock mechanism that gives those matter particles their mass.
Okay, stepping back then. What does this all really mean for how we should think about the universe? This theory seems to paint a picture of a profoundly different reality. One where fundamental forces, maybe even matter itself, aren't truly fundamental, but are more like echoes, resonances, ripples in a deeper ocean of coherence.
That's a great way to put it. Connecting it back to the bigger picture, it really implies that classical electromagnetism is not a law of nature per se, but a dimensional echo. It's just a simplified, linear projection of much more complex, nonlinear resonance behavior that's actually arising from these deeper coherence field dynamics.
And mass, too.
And mass, similarly, isn't inherent stuff. It's more like a reflection of internal phase topology, a stable twist, a locked phase in the very fabric of coherence.
There's a really evocative quote in the source material. It says, "From the dream of Einstein to the realization of Lindgren's geometric field, the journey of unifying gravity and electromagnetism remains incomplete until coherence is recognized as the true invariant substratum. Only then does geometry become derivative and force become flow."
That's a powerful statement.
It really is. It suggests the true ground floor of reality isn't geometry or forces, but this concept of coherence. And everything else we observe, even space-time and the forces acting within it, just flows from that. Well, we have truly taken a deep dive today into what the source calls the intelligence of coherence itself. We really hope this exploration has sparked maybe some new aha moments for you, and perhaps even offered a whole new lens for looking at the universe around us.
And maybe a final thought to leave you with. If all forces, and even matter, really are emergent phenomena arising from coherence, what might that truly imply about the fundamental nature of reality itself? And what other dimensional echoes, what other unexpected physics might still be out there waiting to be discovered, completely shifting our understanding once again?